Good viewers, we want to try talking about an experiment to determine the standard enthalpy change of neutralization. And we want to give some theoretical explanation before we start the real practicals that is going to be the next video you are going to watch. So now, what is the instrument we use? The instrument used for the determination of standard enthalpy change of neutralization is calorimeter. Calorimeter. We'll show you later. The symbol for what we want to do is delta H, theta N. This delta means change. This H means heat or enthalpy. This theta means standard, and this N means neutralization. So let's look at the diagram of the calorimeter diagram. So the diagram, the calorimeter has two beakers, two containers. One bigger container, inside which you have a smaller container. Now you can improvise by getting two sizes of beaker. One bigger one and a smaller one. Then in between them, you put cotton wool or cork or anything that will not allow heat loss or heat gain from the environment. Lagging. So this time around now, we are using cotton wool, we are using cork, we can use styrofoam. Unlike when we did the standard enthalpy of combustion, we were talking about enamel. Enamel was what we used for that purpose. They can ask you in any jam question, what is the purpose of this cotton wool? This is cotton wool to prevent heat loss to the environment and heat gain from the environment. Then you need a stirrer. A stirrer, I'm going to use a glass rod for that purpose. A stirrer, you need a thermometer. So this is a thermometer. So what we have here is a diagram of a calorimeter. This is a bigger container. Bigger beaker. While this one inside is a smaller beaker. So inside this now, we have a mixture of NaOH and HCl. So that's what we have here. Aqueous. So what is the procedure? Let's look at the procedure in page 2. The procedure for this experiment. So we have seen the diagram. Step 1. Pipette 50 cm³ of 0.1 mole per dm³. NaOH. Pipette it into the calorimeter. Step 2. The next thing to do is that you are going to measure the initial temperature of this. Initial temperature. So, measure the initial temperature of the pipetted NaOH with thermometer. And keep your record, and keep the record. Keep it. Don't misplace it. Then step 2. Step 3. So keep your record now as what? As T1. That temperature you take now, call it T1. The next one, pipette another 50 cm³ of 0.1 mole per dm³ HCl. Now into a separate beaker. This time around, into a separate beaker. Don't go and pour it where you pour NaOH earlier. Pour it inside the beaker first. So the next thing to do, now measure the temperature, the initial temperature of the pipetted HCl, and keep the record as what? T2, temperature 2. Are we together? Temperature 2. Then the next thing to do, point number 5, in page 3 now, point number 5, next thing to do, you have gotten initial temperature for both NaOH and HCl separately. Next thing is, find the mean, find the average temperature as, call that one, your average temperature now as let's say T3, as T3, is equal to T1 plus T2 over 2. That's mean. Are we together now? So keep T3 as the initial temperature. Initial temperature before neutralization. Before neutralization. Then step 6. As fast as possible, very fast, transfer the pipetted HCl transfer it into the calorimeter. Transfer it into the calorimeter containing pipetted what? Pipetted NaOH. Are we following me? So the next thing, you have gotten the initial temperature of the whole thing. The next thing is, very fast as possible, transfer that HCl that you have just gotten the temperature inside the calorimeter to mix with what? NaOH. You will see that a kind of vibration will show you that neutralization reaction is taking place, and the body of that thing will be warm because it's an exothermic reaction. And we have said that in exothermic reaction, the reaction vessel becomes what? Becomes warm. So it will be warm. That means the temperature will not be changed, will not be different. So now, then what do you do? 7. Stir the mixture properly and measure the final temperature. Measure the final temperature of the reaction mixture after neutralization as T4. So the temperature, we now have T4 now, Abi. That's the final temperature. So in page 4, number 8 now, then find the change in temperature. Change in temperature, which is delta A, delta T. You see, remember? Which will now be what? T4 minus T3. Any question on that?
No,
T4, that's your final temperature. Are we there now?
yes,
When after the reaction, the thing is now warmer than before. That's your final temperature. Then the initial temperature, the mean of the temperature of HCl and the temperature of NaOH that you have got, that mean value is the T3. It's not going to be as hot as T4. So take it away from here, you get your temperature change. Are we together? Then, now, notes. Okay, let's look at our specimen results. Specimen results. We want to get some values. Now that we have, okay, what are we going to do? Let's assume that our T1, our T3, our T1 now, the temperature of HCl of the first one, let's assume it is 25 degrees C, what we measure. So, which is the same thing as what? 25 plus 273. Carry your calculator to press and tell him we are converting it to Kelvin. Let's assume that the temperature, the initial temperature,
95.
add it. Is that what you got? Are you sure? 273, 25. This is 8. 298. 298 Kelvin. Now, let's assume that our T2 is 28.5 degrees C. So, which is equal to 28.5 plus 273. So, that gives us what? We have 28.5. 8, 9, 11. 8, 9, 10. 301, 301.5 Kelvin. Please. Now, let's now assume that our T3 now. Let's assume that let's now find the average of this. Our T3 will now be equal to what? 298 plus 301.5 divided by 2. What is our T3 now? Oh yeah, add up the numerator. Are you adding? 298 plus 301.5. 299. 299.75. Have you done everything over 2? You have divided by 2.
Yes.
Now, Kelvin. Now, let's now assume that our T4. Let's assume that our T4 now is, let's say 30.5 degrees C, which is equal as 273 Kelvin plus 30.5. What's our answer? 303.5 Kelvin. Now, then what's now going to be our temperature change? Delta T. Delta T, which is now going to be T4 minus T3. Will now give us what? What's our T4? 303.5. So, which is equal as 303.5 minus what? 301.5. What's our answer?
3.75.
3.75 Kelvin. Now, you should know that we cannot find the delta H, the heat change of.
No, you made a mistake. It's supposed to be 203 minus 299.
Where is the 299?
That is T.
It's average we are dealing with now.
That is T2.
Okay, T3 is okay. Okay, thank you. That's okay. 299.7. God bless you for that. So what's not the answer now?
The same answer.
3.75 Kelvin. Now, our each change of neutralization is what? Is mass change, C change in temperature, right? Then what are we now going to use as our mass? Our mass M will be equal to 50 cm cube, 50 gram plus 50 gram, which is giving us 100 gram. Taking what? Taking 1 cm cube to be equal to 1 gram. So 1 cm cube is equal to 1 gram. So 50 gram will not be what? 50 cm cube will not be what? 50 gram. This experiment we are doing now was the first practical WAEC exam in 1980 something. 1980 something. I saw it. So, but they no longer do it. I don't know why they don't do it again. Maybe because we are dealing with strong acids, so that it will not be harmful to the students that are doing it. Is it thank God? Okay. So why are we now doing it now? If you are thanking God. Okay, let's go to page 5. So we have known all our parameters. We can now say delta H equals to MC theta, change in T, where your M is 100 gram, your C is a constant 4.2 joule per gram per Kelvin. That's specific heat capacity. Then you have your temperature change to be what? Your temperature change is 3.75 Kelvin. So we have all our parameters. We can now substitute into the formula. Our delta A should now be our mass, that is 100 times 4.2 specific capacity times 3.75. My people, multiply this number and give me the answer. 59 point what? Please add it. 100,
It's multiplied, no.
Yes, what do you have? Multiply.
1575.
1575.
Yeah.
That's all right?
Yes.
Yes. This is joule. Joule per mole. Why do we say it's joule? Because the specific capacity you use is joule per gram per Kelvin. Are we together?
Yes, sir.
But this is heat of neutralization, not standard heat of neutralization. Not standard heat of what? Neutralization. Because for it to be a standard heat of neutralization, those 4 conditions must be satisfied. One of the conditions is that the concentration must be 1 mole. Are we there now? Must be 1 mole. But this time, and don't forget, what we use here is 0.1 mole per dm cube. We need to drive that dm cube away so that it remains what? 1 mole. Are we together? So what are we saying? Now what do we have? Don't forget that number of mole is equal to CV over 1000, where C is concentration. Concentration in what? In mole per dm cube or molar. This one, this molar. This molar means what? Mole per dm cube or molar. Then V equals to what? Volume in what? Volume in centimeter cube. Volume in cm cube. Abi? So already, so we want to calculate the number of mole. We want to convert this 0.1 to mole, so that it no longer be mole per dm cube. So number of mole of NaOH or HCl, because I want to avoid doing it 2 times. You understand? Don't forget that the 2 of them are reported. They say pipette 50 cm cube of 0.1 molar. Even here also, we are also pipetting 50 cm cube of 0.1 molar of HCl. So the 2 of them are what we want to convert. So what that means, instead of repeating this thing 2 times, I want to do it once. So what am I doing here? 0.1 times what? What is the volume? 50 over 1000. Please press for me. 0.1 times 50 is what? 5. Then 5 over 1000 is what? 0. Point what?
20.
Press.
200.
0.005.
005 mole.
1 5 will not 5. 1 5.
0.
0.05.
0.05 mole, right?
Yes.
So now from here now you will see that. Let's go and use that side now. Now from what we have done here, this is page 6 now. Now from what we have done there, it shows that 0.05 mole of HCl plus NaOH now reacts to release what? The heat of what? The heat of what? What heat did you get now? 1575 joule per mole. Are we together?
Yes.
But for it to be a standard heat change, it must be 1 mole, not 0.05 mole. So 1 mole now, 1 mole of HCl plus NaOH will react now. We react to release what heat? To release the heat of what? Of X joule per mole. So then what do we have there? We turn this one to equation. That means we have 0.05 over 1 mole is equal to what? What heat here? 1575 over X joule. Mole, joule. So we cross multiply, we have 0.05 X is equal to 1 times 1575. So we have 0.05 X equals to 1575. So our X will now be 1575 divided by 0.05. What's our answer there? Press. 1575 divided by 0.05. What's our answer? 315,000, Abi. So now divide it by 1000. This is 315,000 joule per mole. Then if we are going to convert it to kilojoule, we now divide it by 1000.
Yes.
Over 1000. What's our answer?
315.
315 kilojoule per mole. Now, please, your answer is like this. But because the enthalpy change of neutralization is, now, neutralization reaction itself is an exothermic reaction. You will by yourself put minus. You now say the standard enthalpy change of neutralization is equal to minus 315 kilojoule per mole. You are putting the minus by yourself. It's not inside the calculation. But to show that the reaction is exothermic. How will I know that the reaction is exothermic? When you are doing it, you see that the temperature changes increase.
Yes.
The thing becomes hot. The container becomes hot. So it's exothermic. So you have to put minus by yourself. So, but normally you see that these values are hypothetical values with their theoretical values. Normally we are supposed to get minus 57.4 kilojoule per mole if we have done this one experimentally, which we want to do now. Are we there now? But the objective of this class now is for us to know how they come about that 57.4 kilojoule per mole. How did they do it? I hope you understand it now. So we can off this class now and go to the next video. So watch for the next video where we are going to talk about, we are going to show everything we have said here practically. But take note, caution. What is your caution? Caution. Let's check something to be very careful of. Now, or note. The function of the cotton wool. The function of the cotton wool is to prevent heat loss to the environment or heat gain from the environment. That is why you see that in your refrigerator, if you have an old refrigerator, if the body is already removing, in between two panels, you will see cork in your cooler.
Yes.
It's to prevent heat loss and heat gain. So your cooler is a mini calorimeter. So we are ending this theoretical class here to take up the practical class. God bless you. Bye for now.